ECS is Elastic Cloud Services from AWS. ACS is Azure Container Services from Microsoft Azure. Elastic Container Services from AWS. So why these are required to work on Dockers, to work on containers? So what is the significance of using these tools? Right. So basically for the managing the containers. Right. So we have seen Dockers, we have seen containers, right? So using Docker, we can create the containers out of the image and we can spin up multiple containers, right? So for testing, it is okay. For production, let us say there are huge number of containers, right? And we cannot keep them inside one physical host, right? If that host goes down, all the containers will go down, right? So to take care of that, what we have is the container management tools or container Docker orchestration tools. So these are nothing but Kubernetes, Docker Swarm, Mesos, ECS, and ACS. There are also some other tools, right? So Docker Swarm we have seen. So basically we have manager nodes and we have worker nodes. So from the manager we execute the commands. So that will create the containers on the worker nodes. So we just tell specifically create a container for me and manager will automatically choose the worker node. So in the similar way, here also in Kubernetes also we have something called the master node and we have minion. So from the master we create a pod definition using the YAML file, and that this is like here we specify the desired state of the container, right? So I want one pod to be created. In the pod definition I specify I want one container to be created with this image, and we did not specify on which host it has to be created, on which physical machine it has to be created. So it is again decided by the master. So this is the desired state, and based on the desired state it will create the container, right? So let us say, and this is the actual state. I specify one container has to be created and there will be a one container created, and there will be a kubectl process which is running on all the machines, and that is responsible for the communication between the machines, right? So let us say I have asked it to create 3 containers and I specify different images for the each container. So what happens is, let us say 3 containers are created, and because of any reason one container goes down. Now what happens? There is a difference between the desired state and the actual state, right? Now the Kubernetes detects that there is a difference between the desired state and the actual state. Now it will create one more container on the fly automatically, right? So always Kubernetes checks the desired state and the actual state. So in the YAML file we have specified we should have 3 containers. Maybe in the actual there are 3 containers, but because of any reason, maybe there is a heavy load, or maybe the one of the container is not responding, it has frozen, then Kubernetes will automatically spin up a new container for us to serve the incoming web traffic or to serve the load, right? Is this clear?
So Santosh, is it Docker orchestration tool is what we are Kubernetes? That is the main tool, right, for the Docker orchestration, right?
Right. So these all are the tools for Docker orchestration. So Kubernetes, Docker Swarm, Mesos, ECS, and ACS.
Okay, so they are similar tools, Kubernetes, Docker Swarm. So we can use any of those tools?
Yes, we can use any of those. But Kubernetes is the best among all these tools.
Okay, but for if you have Amazon, you can still use Kubernetes and their ECS also, right?
Yes, so if we have Amazon, we can directly use ECS because that is their native container technology. Directly we can use, or if we want Kubernetes, then we need to install it. If it is ACS, it's directly available on the AWS. This is the service actually. It is provided as a service. So this is actually called CAS, Container as a Service.
Okay.
So
Is
it's like
it?
infrastructure as a service, platform as a service. They also provide container as a service. So that is elastic container services. Here also what do we do is we create a
Yeah.
cluster of EC2 instances. And on top of that, what we create is the containers.
Yeah. Okay.
So
Okay.
the concept is same, either Docker Swarm or Kubernetes or ECS, everything is same. Only thing is we create a cluster and we have a master node that manages all the slaves. And on the master node, we specify like I want my desired state to be this. Then based on that, the Kubernetes or the Docker orchestration tool will spin up the new containers.
Okay. And if you're developing your own private cloud, I don't think so. You have available ECS, right?
Yeah,
ECS is
we don't
only
have it.
available.
Yeah, it's only
Then
for Amazon.
on the Amazon. In that case, you're going to use Kubernetes, and from the and Docker Swarm is also popular or no? A lot of people using that
Docker
one.
Swarm is also popular because it comes by default, native for Docker. So if you install Docker, Docker Swarm also comes by default. But Docker Swarm is very easy to set up. We have seen that it's just 3 commands you execute and Docker Swarm will be done. Whereas Kubernetes setup is complex. Lot of configuration files we need to change. You have to install the packages, start the process and all. But Kubernetes is powerful and it can scale up to thousands of containers because it's already proven. Google used Kubernetes for managing their containers and thousands of containers it can spin up.
Yeah, I heard this Kubernetes is very popular compared to any
And
any
now,
other tools.
in the next release in the Docker, it's not yet come, but from the next release, seems like they are also shipping Kubernetes by default with the Docker.
Oh, so it means if you install Docker, you have already just
Yeah,
a couple
you
of
have,
commands.
right.
Okay.
So that
So are they same vendor on the back?
not yet, not yet. That's in the next release. Next, it's in the pipeline.
Oh,
So from the next
yeah.
release onwards, it seems like Kubernetes will be shipped with Docker. So I don't know. It's like death for Docker Swarm. So people will not be using Docker Swarm. Mostly they'll switch to Kubernetes.
Is those Dockers also available containers can be done on Windows also? Because you said Azure. Azure also use. So we have containers in Azure also.
Yeah, we can create Docker. We can install Docker on Windows as well. On Windows laptop also we can install Docker. Docker also provides a kind of terminal kind of thing wherein we can execute the commands like Docker pull, Docker and all. Just the Docker on Windows also is available.
Oh, okay, so if you install Docker on Windows, so what kind of containers can have from different vendors from Microsoft?
Same
Like you have,
like how we use Docker on Linux. In the similar
yeah.
way, we use Docker and Windows as well. It's exactly same way. Only thing is the installation
Oh,
is different. So there will be something called docker.exe which you install on Windows, and this by default provides a kind of shell in the sense a terminal, and that we can open, and there we can write all the commands, Docker run, Docker pull, all that stuff.
you were saying that in Windows we can run Docker and inside you can run basically, let's say, containers from Ubuntu, right?
Yes. So
Oh, okay.
it's actually, you see, the operating system, it doesn't matter, right? So it only takes a kernel. So even on top of Windows also we have a kernel. So when we create a container, actually the container shares the resources from the hardware, right? So
Okay.
Docker, when you install Docker, it gives a shell kind of thing. If you double click on the Docker shell on the Windows, it will create a icon in the desktop that will directly open something like GitHub, something like this. GitHub it will open, And on the there itself, we can run the commands, we can execute the commands.
Okay, okay, I got you. Yeah, I thought this Docker is only for Linux only. Okay, okay.
For Windows as well.
I think there was something VPC from Amazon we still have to cover. Something I think.
I'll be covering. Yeah.
Okay, okay, okay. That is different thing. Right? VPC is different.
That's different, completely different. So this is basically the orchestration tool, and we'll see how to achieve, let us say, how to get the desired state. If one of the part goes down, what happens? How it spins up the other part, right? So we define the part using the command, kubectl create -f and the name of the YAML file. We used nginx YAML file. So here we specified few things, right? So what is it? First thing is API version. So v1, then we said kind, it's pod, right? So we have specified it as pod. Then we have specified some of the specifications like the name of the container which you want to create, and replicas also we can mention. How many parts we can create, number of parts we want to create, and also we can specify the image from where we want to create the nginx. And here important thing is the indentation. We have to follow the indentation, 2 spaces or whatever, tab or whatever, right? So if we specify like this and when we create, it will create a part. So here the kind is part. So by default, parts are, if one part gets killed and other part will not be created by default. So parts are not created by default if the part goes down. So there are some other types, something called deployment, other is replication control. So these are the different types of kinds. Like pod, we can also create deployment, we can also create replication control. So what is the difference? If pod goes down, this is simply like a kind of development environment. If the pod goes down, it will not create the other pod automatically, right? But whereas, so something like you can say pod or mortal, it's not like immortal, wherein if one goes down, other will be created automatically. But if you specify kind as a deployment or replication controller, if the pod goes down, other pod will be created automatically, right? So that we'll see. We'll create a one pod. So kubectl get nodes. So we have 2 minions ready, which we created in the previous class. Kubectl get pods. Okay, there are pod running. So kubectl get deployments. Okay, let me remove this.
Oh, the deployments is a YAML file, right?
Yeah, it's a YAML. I'll just show this after this. Okay, so there is nothing now. Get pods, no resources found. So by default, so now once Kubernetes is set up, there is nothing now. Let us say I don't have anything. Sorry, not my kubectl. Get pods or get deployments, right? So there is nothing. Now you can create using kubectl, create -f and the YAML file. Now in the YAML file, I created all my YAML files here. prod.yaml. Okay, so here I have created deployment kind as a deployment and API version as, instead of v1, I specified extensions v1 beta 1. So this is the release, something like beta, alpha and all. There are releases of different Kubernetes, right? So this deployment is available from this release, which is beta 1. So I have specified kind as the deployment and the version of as the v1 beta 1. And this is some metadata, something about the container. What kind of container I need and what is the port I want to expose. And I have associated this with a label. So what is label? Simply like a tag, right? So we have tags to identify. If you have thousands of containers, and if you want to identify a container, and if you want to filter out, that we can do using a label, right? So we can list out the containers. If you have 1,000 containers also, if we list with a particular label, it will only give the information about that particular pod, right? So it's just to identify our pod in thousands of pods. So using this, I have specified replicas as 3. So it should create 3 pods when I execute this with kubectl create -f command, right? So I'll just say kubectl create -f engines production.yaml, right? So what I'm trying to create is, earlier we created pod. What I'm creating now is deployment. What is the difference? Pods are mortal. Deployments are immortal. Deployments are used for production. So if any of the pod goes down, it will spin up the pod automatically. How this is achieved? This is taken care by the master. So let us see if it will delete one manually and see whether it will create it, whether it will achieve the desired state.
So Santosh, this YAML file will create the pod, right? Not the containers.
It will create the pod means container only, right? So this.
How many containers is going to create?
So it will create 3 containers because we have given replicas as 3. So in each pod, I have specified 1 container. So this
okay.
Container, right? I have specified. Sorry.
So this file will create the pod and the containers, right?
Exactly. So it will create 3 pods. In each pod, I specified 1 container. We can also specify multiple containers in a single pod. But as of now, I specified only 1 container, and that container has nginx image, right? So now
we don't have to mention anything like pod number something. We don't have to mention that, right? Like pod whatever, right? In the file, we don't have to mention that, right?
Yeah, here we mentioned kind is deployment, or we can specify it as a pod. So if it is a deployment, it is like highly available. So this is the desired state, right? So there are 3 parts. You can also specify kubectl get deployments. If you see, nginx deploy is a name, desired is 3, current is 3, up to date is 3, available is 3. So if I kill one pod, one deployment manually, it should create that automatically. You see, there are 3 pods created, each has 1 container. Now I'll just say kubectl delete.
So there are 3 containers created in one pod, right?
No. 3 pods created with 1 container in each pod.
Oh, okay. So this file is 3 pods and 3 containers, right?
Exactly. So here, actually, there is what I'm creating using that YAML file is 1. It's not pod actually. It's a deployment and 1 container. So 1 deployment has 1 container, and that container is nginx. This is clear, right? So I just specified 1 deployment, 1 container, and the container information. But here I specified replicas is equal to 3, indicating that this will be created 3 times. So 3 pods will be created. Each pod will have 1 container. So 3 containers will be created. Is this clear?
Yeah, that's clear.
Okay. Now, so I said deployments are immortal. Deployments are immortal means we cannot kill them. Even if it is killed, other gets created automatically. So there are 3 pods, 7051, 8P, and D something. So there are 3 pods with different IDs. So it will generate a unique ID. Now let me try to delete one and see if it will create one automatically or not. Sorry, I gave delete 2 times.
Can we, Santosh, create like one pod with 3 containers in a file? Can we do that also?
Yeah, we can do that.
Okay, because you also mentioned that when we delete the container, it will create automatically depending upon the desired state.
Yeah,
But the pod,
trying to.
cannot be created. Only the container can be created, right? That's where confusion is, because you said
See, pod container both are same. Inside the pod there is a container. So what I'm saying is, pod will not be created if it is destroyed automatically. But
okay.
deployment will be created when it is destroyed because of some reason if the container goes down. So where did we specify whether it is a pod or a deployment? In the YAML file. There is something called kind, right, which we specified deployment. So that will decide whether this has to be available or not, right?
So let's say somebody by mistake delete the pod, so it means that it won't, you cannot recreate it won't recreate, right? It's but if somebody if the container goes down, that will be created. This is what you're saying, right?
Yes. So
somebody can delete the pod, just delete pod, or
yeah. So I'm trying to delete that deployment just to see if it will create or not. No, deleting in a sense, nobody will delete it, but because of some reason, let us say because of huge traffic, one of the machine goes down, or software error, hardware error, or it becomes frozen, and there is some issue with the container or the pod. So that should be created. That should be notified as it's not running, and Kubernetes should take care of it automatically, right? Not found. Oh, sorry. I think I had to give pod. Okay, it's deleted. Now let us see whether it will create automatically. See, if you see from earlier to this, or otherwise I'll again delete and again create one. Sorry, we'll delete this. The first one will delete and see whether one will be created automatically. Right? If you see here, this is the one which is deleted, 8pgn6, and now a new one is created with the name. So this is DL QPN is already there, B1xx9 is there. So this is the one which is already created. Container is creating, right? The status is container creating. And if I check now, again it is running. So if I delete one part, delete in the sense I'm just actually simulating the scenario. Something like in production, there are thousands of containers and automatically one container has gone down because of some issue, then Kubernetes will automatically create one pod, right? So it knows that it will always check the health state of all the containers, all the pods. If one of the pod goes down, Kubernetes knows that one pod is going down, and since we have given kind as a deployment, it will spin up a new container automatically. Is this clear?
yes. So those, let's say if we have one pod that has, let's say, 10 containers, right? And if the pod was deleted, I don't know, for some reason somebody deleted or and we have to recreate the pod, it recreates the pod and the 10 containers, right?
Exactly. Yes, it will create.
Okay. Let's say if we don't need 10 containers, we just need one container, we won't be able to create it, right?
So that is the pod definition. So here everything is in terms of pod. We cannot create like containers. It's only pods because pod is the smallest building block of Kubernetes, right?
Okay.
So while defining itself, we define how many containers we need. So if it goes down, it will create automatically. So how many number of containers are there in the pod? All those will be created automatically.
Okay. Do you know, like, normally how many containers people create in a pod? Like whether
it depends on the kind of architecture. So generally, what people does is they create a pod with the multi-layer containers. Let us say they are setting up a web server. Let us say pod as a web server, and one of them they create as Apache, the other they create as a file server, and something related to that. So all these things are bundled or tied together or coupled to form a pod. Right. So this pod will have similar containers. So Apache will serve the incoming web traffic. Some files will be shared on the file server. Something like that. They couple and create a pod.
Okay. Got you. How about if in this pod we have like 10 containers, right? Only one of the containers goes down. Let's say Apache. We have all containers are working fine, but only Apache is down. It's going to create only Apache in the same pod, or it's going to create Apache on a different pod? Or
yeah, it will create in the same pod, because there is something called desired state, right?
Desired
so
state.
in the desired state, we have mentioned like how many pods, how many containers we need, and that many will be created automatically.
Okay. Do you specify desired state for each of the container? Is that something, right? Like one for each of the containers, something like that?
We don't specify the state, but we specify the container name. So obviously, container name, container has to be up.
Okay.
Okay. So this is about Kubernetes. So there are a lot more in depth in Kubernetes, but this is the basic thing, like how to set up, how to create, how to list out different commands, and how to if one of the pod goes down, what happens. So this is what we have seen.